Hello, I am Fathum. My index number is 4911. In this demonstration, I would like to present about design patterns in OOP. In OOP, these design patterns are founded by experts to overcome the issues while developing software or program. There are three main types of design patterns: creational, structural, and behavioral. If the requirement asks to create an object, then we can use creational patterns. And when two objects are connected to one is need to use the other one, or some features want to share with those two objects, then we can use structural patterns. Uh, and think that we need to communicate between two objects. In this case, we can use behavioral design patterns. So I would like to explain some design patterns for each design pattern. So let's discuss about build pattern. This is a type of creational pattern. Actually, the build pattern is used for construct complex object in step by step. You know that we can use constructors with many parameters or relying on number of setter methods to do this. But the build pattern provides a more flexible and readable way to create the object. Let's discuss with some key concepts. First of all, we need a product. So I take the example as a computer, and we are going to produce a computer with using these variables. So I define private variables in here and created a constructor for assign those values to uh, these variables, and toString method used to return the uh, values as a string. So next we want to create an interface. So in here I created an interface and define some methods to set the different parts of the computer. And in here I created a method to build the final product. So the next one is we need to create concrete builders. So in here I created a concrete builder to uh, build a desktop computer by implementing a computer builder interface, and I define some variables in here, and we need to implement some specific settings in here. So I uh, set the variables in here, as well as the desktop computer. I created a laptop computer also by implementing computer builders and defining variables and setting these things. So the next one is we need to create a director class to uh, coordinate the construction process by using the builder interface and to assemble the product. So in main class, I created a director uh, instance for the director class. And for the computer and desktop computer and the laptop, I created the build. I called the build method in the desktop builder and the laptop builder. Uh, so the builder pattern is very important to create objects, to create complex object in step by step easily, and it is very easy to create a readable and very structural way of code. So that's about the builder pattern. So let's discuss about facade pattern. This is a type of structural design pattern. In here also, I would like to explain this with some keywords. So First of all, I define some subsystems, subsystem classes. In here, we can represent complex subsystems that has many methods, behaviors, and some other things. So I created in here CPU, RAM, operating system, and the hard drive classes with the method of attaching each and every one. And in here to see the code, I created a system of interlink. So the next keyword is the facade class I created in here, public class named computer facade, and I define those variables in private in here, and created a constructor that initiate the subsystem components, and it ensures the facade has all the components that it needs to assemble the computer. So I created a method named assemble compute in here that is for orchestrates the entire process of assembling a computer. And additionally, I created error handling for this. So finally, in the main class, I created a new instance named computer facade in the computer facade class and called the assemble computer method in here. In here, it's gathering these methods to the facade class and give the result like this. So the facade pattern is used to provide a simple interface to a complex system. In this example also, you can see that the computer facade class acts as a facade, offering a straightforward method to start the computer. Build the computer, while internally managing the intricate interactions between subsystem, and this makes the final code or main code or the client code very clean and readable and decoupled from the implementation details of the subsystem. Okay, let's discuss about the command pattern. I use the same scenario for this also. So let's go with the key concepts. So first of all, we need to create the command class, and in here I created a command interface for all concrete command classes and execute method to represent the actions that each command can perform. Then we want to create concrete command classes. So in here I created install CPU command class, as well as hard drive, operating system, and RAM also. In each command class implements the command interface and encapsulates specific actions. This each class delegates the execution of a command to receive object. So let's discuss about the receiver. This contains methods that perform the actual work associated with each command. These commands decouple the request from the receiver. So we need invoke class for this. So I created a computer assembler class as the invoker. In here I imported array list to store the command list. And this is for managing and the invoking commands. In here, aggregate the execute commands without knowing the specific details of how each command is executed. And this is for store command list and execute each list by calling execute method. Okay, in the main class, initiate the commands and sets up the invokers with the commands in here. So in here, the user can decide which command to execute and what is the order that they need to execute. But it doesn't need to know the specific details of how each are implemented. So the command pattern is a behavioral design pattern. The used concept under this is encapsulation. In here, command pattern encapsulate requests and as an object, thereby decoupling the sender from receiver and providing a flexible way to handle a variety of requests. Rather than it supports to undo operations by maintaining a history of commands executed that are listed, and composite multiple commands allowing complex operations to be treated as a single command. And so the command design pattern is also very useful in designing. That's all about my presentation, and thank you.